Yeah, so for those of you that were here on the previous talk, I'm going to show a different way that's also not RESTful to do things. So yeah. Let me start with a little bit about myself. I'm a software developer, a company called Rackspace, which many of you probably know. There's an office in London that's pretty big, and I think a couple others in Europe. But I work in the US. I wrote the Flask Mega tutorial, which is apparently the tutorial that most people go to when they after they read the official docs. Also the O'Reilly Flask web development book that I was surprised to see that it was given as a freebie to many people here. So great. Every day I work with APIs, microservices, and Socket.io, which is one of the main topics of this talk, my most popular open source project. And in terms of languages, Python is my main language. I do a little bit of JavaScript. There's going to be some JavaScript here too. Sorry. I've also done a lot of work with C++ in the past. And you have my Twitter, my blog. Lots of stuff about Flask on my blog, so if you haven't seen it, check it out. And then on GitHub, you can see my open source. So this is going to be about WebSocket, but we're not going to use WebSocket directly. But I'm going to start from the beginning. And basically, for those of you that don't know what WebSocket is, hopefully you know what HTTP is and how REST APIs work. So I'm going to tell you what the main differences are. And really, WebSocket is a different way to do things. With HTTP, you probably know this, the client sends a request and then the server sends a response, right? And that's pretty much all there is, right? There's a lot of possibilities, but it's all limited to that interaction, request-response. So WebSocket, it's completely different. When the client connects, a permanent link is established that doesn't go away like HTTP. In HTTP, each request is a separate connection. So here, the client connects, and then you have a connection that remains permanent. And then any side can send to the other side freely. Okay, so that's the main difference. Because this is not HTTP, there's no headers, all that verbosity that HTTP has, that's all gone. When you send something, there's a very tiny wrapper around it, but it's mostly your something that goes through the wire. There's no extra stuff. So it's very lightweight. Ideal if you have a home project on a low-powered or under-powered device, such a Raspberry Pi, those type of things. WebSocket works really well because it's more lightweight than HTTP. Works in pretty much any browser except Internet Explorer 9 or older. So if you need to support those people, yeah, you have a problem. But in general, works well, even mobile, they're all supported. And the newer Internet Explorer 10 and Edge do have it. So the most recent Windows users can get this. So I think that's all I'm going to say about WebSocket, because as I said before, I'm not going to use WebSocket directly. There's this protocol that's called Socket.io, and this is yet a different way. That it's not like WebSocket. It's a different way where clients and servers can communicate. And this is built on top of WebSocket and also HTTP. It uses both underneath. You don't have to worry about that yourself. And now you know a little bit about WebSocket. So let me tell you the differences between WebSocket and Socket.io. And Socket.io is great because if you do have a user that's on IE9, the Socket.io protocol will automatically and transparently switch to HTTP long polling, which is a crappy way to emulate a permanent connection. But if the crappy way is the only way, then you can support that user. right? So it does it for you transparently. You don't have to worry about it in your code. You don't need to handle that as a special case. So that's very nice. And then something that I'm going to enforce when we move to the example portion of this, there's going to be some demos here in a little bit. So the main thing that I like about Socket.io is that you can think of it as a way for the server code to invoke a function in the client, calling a function, or the client to call a function in the server. That's pretty much, you write a function on one side, and then the other side can call it. So that's basically, in my view, why Socket.io is great. In addition to that, if you have a client that loses the connection, Socket.io reconnects by itself when the connection's back. You don't have to worry about that either. It does it for you. WebSocket doesn't do that. And then one other important change, compared to WebSocket, is that the server, which knows about all the clients that are connected, has the option to broadcast. So basically, call a function or invoke. We call it invoke an event, but it's technically it calls a function on all the clients with one call. So Socket.io is not something that's from the Python world. It was invented in the JavaScript world. There's an official server for JavaScript that's maintained by the Socket.io organization, a group of people that work on it. And that same group of people maintain 4 clients. So you need software on both sides, right? You need a Socket.io server and a Socket.io client. And so they have the JavaScript server, and then they have a JavaScript client. And then they also have a Swift one, a Java one, and a C++ one. So basically, with all these clients, they cover web browsers, iOS, Android, and video games, which are the main areas where this can be useful. And besides that, there are many community ports of servers and clients. So these are not the only options. So let's talk about the Python side. And Python has a server and a client. The server is called Python Socket.io, and this is my project. This is the project that I'm selling you today. Basically, if you have a web application written on any of the standard WSGI frameworks, you can add Socket.io to that application. And basically, it extends your application to support this, in addition to whatever you do with HTTP. It also supports Async.io. So if you're not into WSGI and you're into the more modern asynchronous web servers, I'm currently supporting AIO, HTTP, and Sanic. Sanic is a framework that's very similar to Flask, but it's in the Async.io side. Flask does not support Async.io. So specifically for Flask, which you probably know this, I like Flask a little bit. So I created a wrapper around the basic service, the Python Socket.io package. That's called Flask Socket.io. That makes it a little bit nicer, the integration with Flask's features. So those are the options for the server. There's a client called Socket.io client that I did not write, so this is not my project, but it works really well as a client for my server. So if you need to write unit tests, for example, or integration tests that you want to make them all in Python, you can use this client, and it works really well. You probably heard that when you work with WebSocket or any WebSocket-related technology, you need to go async. So I wanted to explain why a little bit. As I said before, when a client connects, there's a permanent connection, right? That connection doesn't go away. So if you know how web servers work, when a client sends an HTTP request, there's a worker that's allocated to that client. The worker does whatever the client requested, generates response, and then that connection ends, and the worker returns to the free pool of workers, right, to take on the next request. So this is going to be a request that's going to last for a very long time. So when a worker is assigned to that request, it's going to stay there for a long time. So if you have a standard, like a G unicorn server with 4 workers, right, a typical thing, you can support 4 clients, and then you're gone, right? You don't have any more free ones. So you can use a multi-threaded server, you can start more processes, but really, in practical terms, if you need to support a large number of clients, the only feasible option is to use async, because async workers are very lightweight and cheap. So you can have too many of them. Much more clients than that you will have with any of the others, with threads or processes. So basically, that's the idea. And if you're doing Whiskey, which is not async, the way my Socket.io server supports those applications is by using G-event or event-let. We have a way to magically make an application that's not async. Without you having to change anything, so it's not a problem. Don't get scared. Yeah, there we go. So what I planned for the rest is I have 5 examples. There's a repository with the code. So this is a single application. If you install it later and you want to play with it, it's going to give you a choice to select which of the 5 examples you want to run. The examples are separate, independent, but yeah, they're all started from the same, from this application. So they're all Python server and JavaScript clients, so they're all running the browser for the client. And the README has instructions if you want to run this. Right now I'm running it. So let's get into it. The first one, it's boring because everyone that does an example on on WebSocket or anything related, even Socket.io, they say, okay, let's do chat, right? So this is the simplest and most boring one. But I'm going to up the ante here, and for those of you that want to try this right now, you can go to that URL or scan the code. I'm going to give you, I don't know, 15 seconds. Let's see if we can break the hotel Wi-Fi. Okay, so the next page will show the URL, so if you can still connect by typing. Okay, so yeah, you're there, right? So there you go. They're using it. So yeah, this is a chat, right? Boring. If you are bored by my talk, then you can still use it. It's still up, but I'm going to switch back to tell you how this works. So this is pseudocode, but it's and all the examples I'm going to show they're all that they have pseudocode. The JavaScript side, it's more pseudo than code. The Python side is more code than pseudo. That probably tells you something, but I'm not going to go into that. So on the server side, you create a Socket.io server at the top. This is the right side. And then at the bottom, you run the server, right? So that's all you need to do. And then you create functions that are given an event name. And that's the Socket.io.on that you see these 3 functions decorated with. So basically, that's how you build a server. You create the functions that now the client can invoke. And then on the client side, it's pretty much the same thing. So you can see on the client, the top line connects, and basically that triggers the connect handler to run on the server. And then this gives you the opportunity to authenticate if you need to. Anything that I put in italics, that's hand-waving pseudocode. If you look at the examples on the repo, this is all implemented, but here I need to save space. So if you return false from a connect handler, then that client is it's not given access. But then if you like the client, then you can call the emit function, which is the way you invoke something on the other side. And I'm going to emit an event called message and then passing some text. And for this specific one, I'm saying broadcast it. So it's going to send it to everyone. Everyone that's connected will get this. And basically that triggers a message event handler on the client to run, and in this particular case for all the clients. And they get the message, and then you use some JavaScript to show it, right? And this is running on all the clients. And then at some point, someone is going to type something, and the JavaScript has an event handler for when you press enter, right? And that's the post message on change. And then there, I just emit this other thing called post message, and I have a decorated function with that event name. So that triggers a call into my function on the server. And there, all I do is one more emit that broadcast what this person typed to everyone else, including the person that typed it. Eventually, you're going to go away, and I don't have a way to easily show it with an arrow here, but if you go away, the disconnect event handler will be invoked on the server. Anytime someone goes away, then that happens. So basically what I do there is I send another broadcast saying user whatever went away. And that's how you can see who comes and who goes. So easy? Okay, good. So I'm going to start with the interesting ones now. There are a bunch of other things that people tend to not demonstrate when you use Socket.io. So I tried to come up with 4 more original examples. And this one is audio streaming, but it's actually streaming. We can call it reverse streaming because it's going to be the client streaming to the server, which is not what you think about when you think about streaming. Okay, so this looks pretty cool. I didn't write this. I stole this from an open source audio demo, which is my machine here is constantly recording audio and displaying a nice, colorful thing that shows that it is recording. But the original example from which I stole this, it's a demo to record on the web browser, which I didn't care about. So I took the nice part, which is this monitoring, and then I changed it so that when I press the record button, it's going to start streaming the audio to the server, and the server will record it. So I'm going to go ahead. Hope it works. I'm going to just say a couple things. I could keep this running essentially for hours, and it'll continue to record for as long as you have space on the server. So I'm going to stop. And now I have this. This is a WAV file. So the server records WAV files, and now it shows me the WAV file. And now I'm going to use the browser's own streaming. This is not done by me to play that WAV file, just to make sure that you believe me. Hopefully you'll pick up. Oh, okay, one demo needs to. Okay, yeah, it didn't record, great. Oh, you know what, I think it's going through the, I have the HDMI plugged, so that might be it. Okay, I'm sorry, trust me. Oh, I hate it when that happens. Okay, yeah, you're gonna have to trust me or try it yourself. The way this works is same style, right? There are functions on the server, functions on the client, and starting from the client, the toggle recording is a JavaScript event handler for the record button. So whenever I start recording, so this is constantly receiving the audio from JavaScript. This is done with JavaScript APIs, right? But the audio is used to generate that bar graph and then thrown away. As soon as you press the record button, I send a start recording event that calls the start recording function of the server. I'm using, maybe you don't know this, a lot of people don't know this, but Python, the standard library, has a wave module that writes wave files. That's very handy. So I configure a web file with the Python standard library. And then I store the name, which is a UUID4, just a random name, and the actual wave file object in the session. And session is basically a user session. And then as soon as the recording flag is set to true on the client is going to start sending those chunks of audio that receives in an event to the server. So it's going to call the write audio, and then write audio, the only thing it does is write the chunk. So this is going to be very small chunks, so under a second of audio in each chunk, and it's constantly sending those. So it's streaming, basically. So it's writing them. And then at some point, this is going to end, and if you look at the toggle recording, it also handles the case when you stop the recording, and that's going to call a different event, end recording. End recording closes the WAV file, which is already there, so there's no processing to do, and then it sends an event to the other side saying, hey, I have a new WAV file, and that's what puts it in the bottom side, and then you can play it. So this is the way you can stream audio. You can apply the same technique to video. And you can also do it the other side, right? You can have the server stream using this mechanism in the same way. Okay. So something that's a little bit more, it's sort of similar, but a little bit more elaborated, is to do file uploads, which in my opinion is the most disgusting task you should be, you can ever do in the world of web development. It's so awful, so primitive, even in 2017, right? So yeah, I don't like the way that works. And really, if you think about it, you're just copying a file from here to there, right? And if you had to do it, if you had to code a file copy, you just do a for loop, right? And read a chunk, write it, read another chunk, write it. So that's what I did, basically, using this. So this is a demo. I'm going to open a file. This is a Chromebook, by the way. That's why it looks strange. It's not a real machine. So I'm going to select a bunch of files. I made files of different sizes, right? And there are some dubious ones, right? As well. So I'm going to drop them there. And then when I press this, it's going to upload from the client to the server. So there goes. Right? So this is, I mean, if you had to do this, think about it. It's awful, right? It's super hard. How do you even begin, right? So yeah, I did it by basically copying chunks in the way you will normally do it. And I'm going to close this guy out of the way. And basically, this is the pseudocode. There's the server has a start and a write, 2 events. That's it. So when the client has when the user clicks the upload button on the client, then that triggers an emit to start the transfer. And this is for security purposes. When the client sends a file name, I don't trust that file name. I'm not going to write the file with that file name, because that file name could be .. .. and then who knows where it can go, and I'm lazy, I don't want to validate. So what I do is I come up with my own name, so a UUID4. Oh, I'm sorry. First, I look at the extension, and if it's an extension that I don't like, I just return false. Okay? And return values are important, and this is something that this example showcases. If you look at the client asks for a callback. So when the client sends calls emit, and then in the last argument passes a callback function, then that callback will be called with whatever you return on the server, which makes it very, very convenient. So when I return false, it goes into the transfer callback, and the first thing it checks is if the file name didn't come through, then it basically puts that red bar that you saw in the example. But then if the file is okay, then it creates a name for it, a UUID4. It creates the file, it does some admin stuff to make space for the file, and then it returns this file name that the server assigned to that same callback. So then in JavaScript, when you have the new file name, all you need to do is you need to use the JavaScript APIs that let you read the file, and for each chunk that you read, you just send it to the server, and the server writes it. And at the same time, it can update the progress bar. That now it's just a UI work. You don't have to be complicated with all the awkwardness of the HTTP uploads, which are super primitive. So when it writes a chunk, it also requests a callback, and this gives you the option. I'm not doing that here, but it gives you the option when you receive the first few chunks or the first chunk, you can look at the contents. That if you find that this is a .jpeg file, but you analyze the contents and it looks like it's not a JPEG file, you can return false, and that callback will also make it red and stop it. So you have a lot of control. Okay? Are we doing on time? Okay, we're good. There's hope. So, okay. So there are two remaining examples. Both are an attempt. I said it joking before, but I'm really going to try to break the conference Wi-Fi now. If it doesn't break with this one, it'll definitely break with the final one. So, okay. So this one also has a place where you go. So I'm going to give you a few seconds. Okay. So let's see how that works. Switch here. So this, okay, so it's working, yay. So for those of you that are not doing this, I'm going to show you how this looks for you, which is not how it looks for me. Right, so you get this, right, and you can vote here. There you go, I voted. So, and in real time, this is keeping a tally of all your votes, and you can even go change it, and it'll update real time. What we have, mostly experienced people, Python 3 yay, Flask super yay, or are you doing it because I'm here looking? I don't know. And none of the languages I picked appear to be people's favorites. Okay, interesting. Anyway, okay, I didn't break it. Okay, I'm going to try again soon. In a little bit, I'm going to tell you how this is built. This also probably sounds difficult, right? And it's also this weird thing where you're seeing something and I'm seeing something else, right? It's like two applications here, right? So let's look at that. So really, there's only one application in the server, but there are two client applications, right? I sent you to one, and then I'm showing you the other one. Something that Socket.io has that's very useful for this type of thing, it's called namespaces. Basically, you can have a server that sort of supports two or more different classes of communications. So basically, this server knows how to talk to admins, which is what you saw here in the screen, and also knows how to talk to voters, which are all of you, right? And it's not going to allow you to access the messages or events from the other class, right? You're constricted to the communications that you are on. So if you look at so this top one is you, and the bottom one is me in the client, and then we have a server. So here, when I connect, I say I give a namespace name, and that's called polls. And then in my case, I'm using polls admin. So the server now can listen to those two, And in the decorator, I specify which. So I decide which type of event, for which type of user each event belongs. So when you go and vote, each time you click on one of those boxes, that sends a vote event with your selection, and then on the server, I just store it in memory. So this is a single worker example. I'm running a single worker, so I can use memory. I don't need to use a database. If I had multiple workers, I would use a database. But anyway, it's in memory, so it keeps a tally in memory, right? And then when I connect, basically I connect, and there's a connect event for admins, and what that does is emits the current state of that tally, right? All the answers, which are just a few numbers. It's a small payload, right? So it's just the height of all those bars, right? But then you're constantly changing things, right? And I wanted the bars to update as you do your changes. So I also created a background task, that's update task, and then that I started with a utility function from Socket.io from the server, start background task, but really that it's a background thread, so that there's no mystery there. And then that task basically runs a endless loop, sleeps for 5 seconds, and then it broadcasts to all the connected admins that state, the state of that memory that holds all the votes. So every 5 seconds, it updates it. So I think it's pretty simple. I wrote this application with all the hand-waving JavaScript and all the bells and whistles in maybe 3 hours. So I was pretty satisfied. And of course, the tool that I use for the bars, it's an open source project, so I didn't write that myself. It was a JavaScript library. But anyway, still, I think it was easy and fun. Most importantly, fun. So, okay. So the next one is it demonstrates it builds on the previous one. So it's also you're going to participate. So get your phones ready, and it builds on the previous one. The previous one you saw that whenever you interacted with the server interacted with you, and when the admin application interacted with the server interacted with the admins, right? This one demonstrates something that's more interesting, which is to cross communicate. So that demonstrates that really, I mean, you're thinking that there are 2 applications, but there's really one. So basically, when you go there, you're going to get a map, and you just need to put a pin where you live, or whatever, the place that you like. Doesn't matter. And in this case, I am going to, oops. Yeah, there you go, it's working. Right? This is surprisingly simple to do. I'm going to show you, but wow, hyperactive. So who's from Argentina? I'm Argentinian, by the way. Oh, there you go. Okay, great. Okay, so it didn't break. With 40 people, it didn't break. I thought that everybody unloading maps all at the same time is going to be some major catastrophe, but turns out it's fine. Great for the hotel. Congrats. Okay, so this is actually written in the same style as the previous one. So there are 2 client applications and 1 server, and I'm going to show you my side first. Again, there are 2 namespaces. So polls and polls admin. When polls admin connects, the server sends a list of all the pins that it keeps in memory, right? So that it can show an initial view of all of you, right? Not knowing nothing, it needs the whole list. But then to make it efficient, the previous one had a small payload, so every 5 seconds it sent all the bars, right? Now, for this one, it will require sending 40 or potentially more, right? This type of application supports really high number of clients, right? We can easily talk into thousands, right? So it's really impractical to send a lot of data very often, right? It's wasteful because most people probably are going to set the pin and never change it, right? So the way that works is when you drop your pin, the handler on the server, which is associated with the, I'm sorry, I have a bug here. On the right side, these two copy-paste error. This should be where and where admin. And this is wrong too. Look at that. Right, so these should be matching. So this is going to send to this one, but then I want this guy, which handles, the regular user namespace, to send to all the admins and update only that one pin. So it sends the broadcast to all the admins and then overrides the default, which is to reply to the same namespace by setting a new namespace. So yeah, I mean, that's all there is to say. It's actually super simple. And after I had the other one written, this one was 1 hour. And most of that hour was figuring out the Google Maps API. So I hope that I sort of gave you the itch to go try this, try my examples or come up with other examples. There's documentation. I wrote a full documentation for the framework agnostic package, Python socket.io, the Flask specific one, Flask socket.io. There's examples. I even wrote an example for Django once. So just to demonstrate that this is not all about Flask. There are examples for Async.io frameworks as well, if you want to see them. I get a notification when someone posts a question to Stack Overflow about any of these. They have tags, right? So I typically answer all of them in a day or less. You can tweet me if you have a question that's urgent. And I'd like contributions. Some of the great things that I have were not written by me, were contributions. So yeah, I mean, if you come up with an idea for a new feature, even if you're not completely sure how to implement it, reach out, and I mean, I can coach you, give you ideas, whatever. If you want to write like I did with Flask socket.io, a wrapper that's nicer integration for another framework, I'm super interested. Unfortunately, I don't think I will do a good job if I attempted, for example, a Django wrapper, because I don't use Django a lot. But if you do, and you want to, I mean, you want my help and design something that's really good for Django users, let me know. New examples, whatever else, yeah, please contribute. So yeah, that's it. Thank you. So if there are questions, I'll
have some time for questions. So, anyone?
Hi. Thanks very much. Very interesting talk and really nice examples. Nice to go beyond standard chat. One question that comes up with asynchronous stuff in Python is that what do you do when you need to have a combination of standard requests that are going to have some CPU intensive tasks that might block, and where you need to do the asynchronous chat socket.io stuff? Right.
Yeah. So you don't, right? Because if you run something that's CPU intensive, async applications are running one thread, right? So if you do a lot of work, then the web server does not get the CPU, right? So you need to offload that. Typically, you can use an executor. You can use a celery job. Anything that takes that CPU-intensive work to a different thread, or even better, a different process, a different CPU, which will. a different process which will have access to run on a different CPU if you have more than one, which you probably do. And then the server, it basically is unaffected by all that work.
And sorry, one slightly extra question.
Yeah.
Would you do the same thing for database access? Because usually it is blocking. Or would you?
Well, so it depends. So there are async wrappers for databases. Specifically for async I/O, there are packages for, I think, at least for MySQL and Postgres, you do have them. If you're using WSGI applications, you're required to use gEvent or event-let, which basically make everything async in a sort of a magical way, right? By monkey patching the standard library. So any databases accesses that you use under gEvent or event-let will be async magically, and almost always it works.
Okay, thank you.
Yeah.
Another question?
Hi. If I recall correctly, Socket.io relies on WebSockets. Do you know if it will ever support WebRTC or ORTC or those kind of technologies?
It will not on its own, right? This is straight WebSocket, but there's no reason not to implement this on top.
Okay, thank you.
Mm-hmm.
Do we have any other questions? I don't. Okay.
One more.
What would be the best strategy for debugging it?
For debugging?
Yeah.
So if you've been on the previous talk, your talk, you can call these functions. Yeah, very good. I like that. So basically, these event handlers, they get decorated, but the decorator doesn't really do much. It just registers the function to basically registers the function with the framework, right? So if you need to debug it, you can just from a Python session, you can just call the function, pass the arguments that you want, see what the response is. If you need to use a debugger, there's no magic. They're really Python functions, so you can put a breakpoint with a debugger. PyCharm works really well. Visual Studio Code works well. PDB works well. I've used all of those to debug applications that use this. So yeah, there's really no difference with what you do with other, more standard Python code.
Thank you.
Yep.
Do we have any more questions? Okay, I don't see anyone, so let's thank again our speaker.
Okay. Thank you.